In this clip, we'll look at the different generations of the double data rate or DDR standard. It turns out that there are several such generations that we might encounter in the field. The newer ones make improvements in one or more of these three areas: speed, size, and power consumption, lower being better, especially for mobile devices. Now, if we already have a motherboard to which we'd like to add RAM, we won't have a choice as to which generation DDR to use. The motherboard will dictate it. And we don't have backwards compatibility either, because different generations of DDR RAM can use different DC voltages and different physical connectors, pins and notches. So in general, DDR RAM modules are not interchangeable between generations. Here's an overview of the development of RAM technology over the last couple of decades. Before DDR, we used something called SDRAM, which could only read and write once per clock cycle of the CPU. Now in 2000, DDR doubled that data rate, hence the name DDR. Since then, speed and capacity has continued to go up, and power consumption has continued to go down, all while maintaining very high reliability. In 2003, we saw the advent of dual-channel mode, in which module pairs improved performance by letting the CPU access two different RAM modules at the same time. 2007 brought us DDR3, with approximately double the speed of DDR2 and dramatically lower power requirements. Great news for laptop users. The DDR4 generation made improvements in both the power usage area and the performance area, and today's DDR5 took yet another big speed jump and also increased the maximum module capacity. Modern computers today usually use DDR5 modules. So that you can more easily recognize different generations of DDR RAM in the wild, I thought I'd show you a few photographs. Here's an older DDR module. It's a SO-DIMM taken from a laptop. Notice that it has 200 pins. You can trust me on this, but count them if you like, and a positioning notch pretty far over on the side. Here is a newer SO-DIMM, this one having 260 pins and a notch that's slightly off-center, but much closer to the middle than in the DDR2 module. Here's what a typical DDR3 DIMM looks like, both front and back views. This module is for use in a desktop PC. The pin count here is 240, with a notch that is somewhat off-center. This slide reveals a DDR4 DIMM with 288 pins and a very slightly off-center notch. And by the way, do you see the number of rectangular chips? It's 8, which is quite common given that there are 8 bits in a byte. Now my last photos show a modern DDR5 DIMM, which also happens to have 288 pins, but the positioning notch is closer to the center than the DDR4 module we just saw. This particular module hides the 8 chips. You can just barely see their designations right above the contact pins, because it uses a heat spreader to help dissipate the heat that these chips generate. There's a certain amount of debate about the need for heat spreaders, but anything that helps delocalize hotspots is probably a good thing. And you can't see it easily in this photo, but along the top of the module is an LED light bar to make the RAM modules look cool inside a transparent or semi-transparent computer enclosure. Now, some of you may be asking, what about absolute speed measurements for these different DDR generations? Well, I'll give you some. The original DDR could move data around at somewhere between 2 and 3 gigabytes per second. DDR2 doubled that rate. DDR3 doubled it again, or a little bit more. DDR4 ramped up the transfer rate still further, and DDR5 more or less doubled DDR4. You may be detecting a pattern here. The reason that there's a range is that the actual data transfer rate in a specific machine can depend on several factors beyond the DDR generation. But we can definitely see that when it comes to DDR generations, newer is better.